I'm Matt Swartley with Chariot Solutions, and I would like to introduce you to Ryan Gallagher, who is the Director of Engineering at NeuroFlow. He is an experienced mobile engineer skilled in a variety of mobile technologies. Today, Ryan is going to speak with us about the ins and outs of migrating an existing native mobile application to Flutter. So please welcome Ryan Gallagher.
Thanks, Matt. Appreciate the intro. Hi, everybody. I'm super excited to give this talk. This is kind of a new world for me, so hopefully I can teach you guys something, and maybe with the Q&A at the end, you can teach me something too. So really excited to give the presentation and super excited for a collaborative conversation at the end. So like Matt said, the conversation is going to be a little bit about a journey that we at NeuroFlow have gone on over the last 8 months to start migrating our existing native iOS and Android mobile apps over to Flutter. And so I'm going to kind of talk about a couple different things. I first want to mention there's going to be a mix of kind of subjective and objective findings. Some things that are like unique to our situation being like a Series B startup, but then some objective findings like, architecture pros and cons of doing some of the Flutter migration type stuff. So we're going to break the talk down into 3 sections. The first is going to be how we settled on Flutter. So a little bit of a compare and contrast between Flutter and React Native. The second section is going to be like stakeholder buy-in. So once you as a developer or whoever you might be are super excited that like Flutter is the future for your company, how do you kind of socialize that to everybody else? And then the third part is going to be digging a little deeper into the architecture. So if you're not as technically inclined towards that third part of the section, feel free to disengage until the Q&A maybe. All right. So first of all, it's just 2 minutes on kind of me and the company I work for. Like Matt said, I'm a director of engineering at NeuroFlow, but I also want to call out because I think it's important to the content of this talk. I am a engineer with 10 plus years of native iOS and Android experience. And despite whatever the title may mean, I do try to spend 30 to 50% of my time still doing individual contributor work. I think it's super valuable to kind of A, keep up with tech, and B, have like a very in-depth view of like boots on the ground perspective. Also want to call out, I am not going to know everything about every one of your questions possibly. Flutter is a new technology. We're relatively new to migrating to it. So I'm going to show you as much as I can, but just, have that kind of in mind. So company I work for, just real quick, part of the subjective conversation here is that NeuroFlow is a Series B startup. So depending on, in the second part of the talk, when we kind of discuss stakeholder buy-in, there's a lot of like subjective realities that might differ depending on the kind of company you work for. So mine will obviously be slated towards the reality I'm living in. And hopefully you can take some good stuff from it regardless. But yeah, so NeuroFlow, healthcare company kind of focused on integrating behavioral and physical wellness. Goals are to, improve patient outcomes, overall wellness, and reduce cost of care. We are being used by tons and tons of giant organizations across the country. We've got, as far as, I guess I should touch on our stack a little bit. We've got Python backend, Postgres database. We're, all in AWS. Native Swift and Kotlin mobile apps, obviously migrated partially to Flutter now, and then a React web component. And want to call out, wouldn't be doing my job if I didn't say this. So we are always hiring great people. If you like the content of the talk or you think the company or its mission are interesting, please reach out afterwards. Would love to speak with anybody. So bottom line up front, this is my attention grabber. 8 months in, we are seeing huge development wins. I'm talking like something that almost doesn't feel like reality in a lot of cases, which is like greater than 50% reduction in development time. I do want to call out some like obvious caveats here. There the greater than 50% kind of reduction is for specific types of tickets. And I'm talking specifically about like hands-on keyboard time, right? Like obviously Agile ceremonies and user acceptance testing and all that stuff doesn't really get the benefit of Flutter. But when I'm talking specifically hands-on keyboard time, we've been able to see some like huge reduction, which is exciting. And as we continue to like add more and more components in Flutter that are then reusable in, other widgets that we show on the screen, that like 50% marker becomes kind of more and more common. And the other is we've been having such kind of a wonderful time migrating to it that I want to share the love. The Flutter community is still kind of small, and I just, want to spread that love. So like I said before, agenda, Flutter versus React Native, little compare and contrast, stakeholder buy-in, and touching on some architectures. First up, no surprise, Flutter versus React Native. And I'm going to throw in a little shout out to Kotlin Multiplatform because I think depending on your, again, subjective situation, could be the right call. So first off, I want to touch on what's the same between kind of React Native and Flutter, right? They're both declarative UIs, which, again, subjective opinion, but are way better than kind of like the imperative standard programming that you get with native iOS and Android. I know like with iOS, you can use Swift UI if you support more than iOS 13. With Android, you can use Jetpack Compose. Those are both declarative UIs, but it's still kind of write twice to run on both iOS and Android. You don't get the write once benefit, but love the kind of enforced separation of responsibilities with the declarative UI. Hot reload. This is a huge reason why some of the development velocity increases we've seen have happened. I mean, if there are any iOS or Android developers in the room, and hopefully there are, like, how unbelievably painful it is to use Xcode in general, but to sit there and like recompile the app when all you've done is made like a tiny text or color change. And you sit there and you wait like minutes on minutes in some cases, just to validate that what you changed has actually happened. Hot reload, you hit save, and doesn't matter what it is, if it's network logic, if it's business logic, UI stuff, you just immediately see the change in the app without recompiling. And I love that. Next up, greenfield and add to app architectures. So again, depends on your situation. Maybe you have the capacity to go, heads down for 6 or 12 months and rewrite your entire application in Flutter. I think for most people that probably won't be a reality. And so both Flutter and React Native support like an add to app architecture, where within your existing native iOS and Android apps, you can basically plug in a Flutter or React Native widget. They both claim to write once and run anywhere. I'll dig a little bit more into why that may not be more or less true for each one. And each obviously has its own syntax, right? You're not writing, you're writing in JavaScript in React Native, and you're writing in Dart in Flutter, not Kotlin or Java and Objective-C or Swift. And that plays in a little bit to the kind of size of the community and adoption. Like a lot more people know JavaScript than know or maybe have even heard of Dart. Okay, so comparative wins. I do want to caveat this again, like maybe Flutter isn't the right way to go for your specific situation. I think it was for ours, but React Native definitely has some pros over Flutter. Maturity and adoption, like when you look at salary guides for development positions, it's iOS, Android, React Native. You don't see any like Cordova or Xamarin or the new one by Microsoft, which I forget the name of, or Flutter even. You see like iOS, Android, React Native. Again, it's in a common language, right? You're writing in JavaScript. Maybe you consider that a win. I don't know. And it's not backed by a company known to quickly abandon failing projects, right? So Flutter, created by Google, used by Google in a bunch of their apps, and seems to be the future of their general app development. like I have it down here in the wins for Flutter, but they run all over the place: iOS, Android, web, desktop, even embedded devices. But I mean, we as tech people know, like, if Google, doesn't see success with a project, they can be pretty quick to just, shut the door on it. Anyway, so wins for Flutter, two biggest ones. And there's obviously a ton more kind of minor ones, but the couple I want to call out, it's not an abstraction layer, right? So I don't know about the new one by Microsoft because I just learned about that from the talk the other day. But React Native and a lot of those other kind of write once, run anywhere technologies are an abstraction layer over top of native widgets. So for example, like you create a list view with a bunch of cells in it in React Native. Like what happens behind the scenes is you get like a UI table view in iOS and like a recycler view in Android. And so like React Native does its best to kind of abstract away the differences between the two. But you can, pretty commonly, I think, run into situations where you have to say, if iOS, do this specific thing, else if Android, do this other specific thing. Whereas Flutter runs in a common C++ rendering library, which does not render down into native widgets. It draws its all own stuff on the screen. So kind of what you see is what you get as far as what you're building in Flutter versus what you see on iOS and Android. Compile time safety. I know like TypeScript is a thing for JavaScript, but Dart is a statically typed language, which is what you write Flutter in. So to each their own. Like more people know JavaScript, but I love, from the perspective of like onboarding new developers and like reducing risk, seeing when something is wrong at compile time. Like, I don't know, can't overstate that. But your mileage may vary. So real quick, what about Kotlin Multiplatform? This is a technology where you can write code in Kotlin and run it on both Android and iOS. But super important call out, it's not the UI, right? There's no UI support here. So you get like business logic, network layers, stuff like that. But again, depending on your situation, like maybe you use Jetpack Compose for Android, Swift UI for iOS, and you're like, hey, I'm okay writing the UIs in their individual, native languages. I would just love to kind of unify all the business logic behind the scenes. Our UI layer is really thin. If that's your situation, maybe check out Kotlin Multiplatform. It's pretty cool. The one downside I ran into when I did a little proof of concept was third-party libraries have to support Kotlin Multiplatform, and not a lot do yet. So again, mileage may vary there, but a lot of like super common libraries that you might use. I don't remember specifically if these do or don't support it, but like retrofit and things like that in Android would have to support KMM. But again, for your situation, maybe it's the move. So why did we go with Flutter, right? Pretty basic. The pros for it were subjectively better for our situation. The fact that it renders its own UI and what you see is what you get, like, hallelujah. Static typing, love it. And platform channels. So platform channels, if anyone has done research into some of these like write once, run anywhere technologies, specifically React Native, you've probably come across or heard about the series of Medium articles by Airbnb that basically go like this. In 2016, 2018, a few years ago, they were like, hey, we're going to start doing everything in React Native, right? And then there were a couple, I think it's a total of 5 articles, but it's like, we're going to do everything in React Native. We're super excited. And then it's like, things aren't going so smooth, not going so smooth. And we're abandoning React Native, like sunsetting React Native, I think is the title of the 5th article. But that really scared us because one of the drawbacks that they call out a lot in that series of articles are the communication method between the React Native code and the actual native code, right? if you're not doing the greenfield architecture approach where you're able to go dark for a year and totally recreate your app from scratch in React Native, you go with the add to app approach where you get the individual React Native or Flutter widget inside your native app. And what they ended up running into was they're like, hey, our developers are spending more time writing like boilerplate, like communication layer stuff between the native code and React code than they're spending writing new features, and so that really kind of scared me personally. And so when I did the original proof of concept for Flutter at NeuroFlow, I spent a lot of time playing with the platform channels. And I'll dig into them a little bit deeper later when we talk about architecture, but they're wonderful. It's super easy. So put a pin in that maybe for now. Just want to talk about results now that we're 8 months in. First off, really expensive upfront, right? And I'll dig into some more specific costs when we talk about the like stakeholder buy-in. But really expensive upfront, obviously, like it would be with any new technology where no one at the company knows it, but huge, improvement in development velocity 8 months on. And I think that's a result of, hot reload. Componentizing different things is really easy for any, iOS or I guess even Android developers in the room. If you use like Storyboard or XIBs in iOS, you know how much of a pain it could be to try to extract like part of a widget you've created into a new XIB that is then reusable all over the place. Like auto layout constraints don't want to save during any kind of like extraction. Can be a huge headache. In Flutter, all the UI code is built in text. There's no kind of GUI UI builder, right? But that allows the IDE to basically, you can just like right click on a widget. If you create a widget with a ton of sub widgets in it, you can just like right click on one of those sub widgets, say extract, and it just does it perfectly. It takes all the parameters out with it. And boom, you've got this like reusable thing. So even if you end up like building a massive one thing to start with, literally it takes 2 seconds per widget to extract that, and now it's a reusable component that you can use for future projects. Really cool stuff. And it's a huge reason why kind of velocity continues to increase over time as we get a larger widget library. And it actually works the same on both iOS and Android. It's hard to measure some of this stuff, but there's been a subjective increase in confidence from design, product, and QA. Design loves that things look exactly the same on iOS and Android. I'm sure people have their own opinions with like, hey, do Android things on Android, do iOS things on iOS. Flutter does that really nicely. For example, even though it renders its own widgets, it's smart enough to say, hey, I'll give you like a bouncy scroll view by default on iOS and a not bouncy scroll view by default on Android. And it's all really, really easy to use. So some of these arguably ancillary benefits, again, any native like iOS or Android developers know how limited the default like set of UI components are that you can work with, especially iOS. Like Apple wants you to use what they give you and nothing else. And if you really do, you're going to have to kind of create your own thing. The library of like pre-created widgets in Flutter is just mind-boggling. Almost everything we've needed to do so far, there's already like a thing out there created by the Flutter dev team that does exactly what we need. And it just saves so much time. Okay. But, obviously nothing's perfect. So there are plenty of frustrations here. And the two main ones are, it's a young community, right? So if you run into an issue, especially with like weird edge cases, weird edge cases, you go to Stack Overflow and there's just not a lot to be found. And so in a lot of cases, you end up going to like the GitHub page for Flutter and like posting questions to the open source developers or to the Google Flutter team. And I've actually, in the last 8 months, I've seen more and more Flutter Stack Overflow posts with like relevant, easily accessible answers. And like any good developer, I spend a decent amount of time on Stack Overflow. The other pain point is kind of flakiness of the ad to app development experience. It does feel like the greenfield approach to Flutter is a little bit more of the primary use case, and the ad to app is relatively feels like a bit of an afterthought. The support in general is wonderful. It works perfectly, but the development experience itself with hot reload, sometimes like, do have to say this. So hot reload, hit command, you hit save and everything reloads like right on the screen, and it preserves state, right? So if you're like 3 screens into a multi-screen flow and it's all in Flutter, you hit save and you immediately see like a color update or something. Hot restart is another thing that Flutter supports. And it's like a folder reload, still almost instant, but it doesn't preserve state. It's like a larger restart. And so like hot restart seems to work perfectly all the time. Hot reload just does not. Sometimes it breaks and then you have to hot restart. So all that to say, still 100 times better than like native iOS and Android development where you have to wait minutes on minutes to recompile, but not as perfect as I suspect it will be in another year or two. All right, next up. So section 2, talking about stakeholder buy-in here. This is like, all right, you're bought into the idea of Flutter, you personally, but how do we kind of get the rest of the company to buy in? How do we get finance to shell out for it? Our product owners excited and all that good stuff. Some of the conversation's really easy, right? It does not take a rocket scientist to understand that like writing everything twice is expensive. And if we could write everything once, it would be way cheaper. Really easy concept to grasp. But what is a challenge is figuring out how to start to layer in Flutter in the right way, right? Again, assuming you can't go dark for 12 months and rewrite this thing from scratch, you've got to balance a lot of short-term and long-term wins, right? The business still needs, feature development to go out, even while you may start to layer in some of this Flutter stuff. Challenge we ran into personally, no one on our team knew Flutter or Dart, so we had to figure out how to, overcome that challenge. Stability is a big one, specifically in our space, although I'm sure everyone feels the same way regardless of space, but we deal at NeuroFlow, we work with a lot of like sensitive populations, people who may have, mental health challenges and all that kind of stuff. And so the last thing we want to do is, frustrate someone with a new feature in Flutter that doesn't quite work when they may be experiencing some sort of like suicidal ideation, So stability is really, really important. And then, for the finance folks, like, hey, what's the ROI here? So we'll take those challenges on one at a time real quick. Balancing the short and long-term wins. I mean, it's super subjective. I think if you're a seed or a Series A company, fighting every day to stay alive, like it doesn't matter if you could have an amazing Flutter app in 12 months, regardless of whether you go dark or not. If you end up going out of business because you focused on all those long-term wins and not on short-term, it's probably just not the right time to consider this kind of thing. For us personally, the kind of post-Series B time period gave us the like breathing room and resources to accomplish it. And then, again, like I've kind of been saying, you have to keep developing features, can't go dark for 6 months. Nobody on the team knows Flutter or Dart. So I firmly believe, a couple points here, firmly believe that this should largely be like a developer-led initiative, because there is a certain amount of like above and beyond involved. If developers aren't bought in, it's going to be a huge uphill battle. They may have to like learn the tech. They're going to have to review pull requests in these new languages. They're going to have to work closely with product managers to help determine which features should be in Flutter versus native code. And if they're not bought in, it's going to be really tough. And so the proposal I have that we ended up going with is to really kickstart it with a third-party developer. I believe, well, I at least find that the best way to understand something new is to, how do I want to say this, already have understood it, right? So if I take a feature in Swift in native iOS and hand it to a third-party contractor and say, hey, use the app-to-app architecture, please, get that started and transition this one feature over into Flutter. It's really easy then to see like, okay, this is how Flutter works because I already knew how it worked, or how the native feature worked in native iOS, right? So I think it kind of serves two purposes. One is jumpstarts the developer knowledge transfer, and also gets your kind of code base set up in the right way because someone who's building it actually knows what they're doing. It puts you in kind of a good starting spot. And I would also give a quick shout out, consider offshore third-party developers there. We ended up personally going with a Ukrainian company that was phenomenal and very inexpensive. And it really kind of put us in a good spot to pick up from there with our internal mobile development team and run with it. And the other important thing is, while I might personally believe that it should kind of be a developer-led initiative, I think everyone should be kind of like bought into, like, just like a Scrum Master should kind of evangelize, like, Scrum, and make sure things are happening the right way. I think developers should kind of evangelize Flutter, right? Like PMs should understand, hey, just because we're going to write something in Flutter rather than iOS and Android, even at the beginning, it's not going to take that much longer, if at all, because you're still writing the thing once. Maybe because you don't know the technology as much, it takes as much time as it would have to write it in iOS plus write it in Android. But at the end of the day, like the diff between iOS and Android and like Flutter, maybe, I don't know, depends on your velocity, but like a couple of points, a couple of like work days. Designers, again, how do I say this? Personally find constraints to sometimes be, no, not constraints, but like there are some things that are tough to match exactly up to design specs. I think, hopefully no one yells at me for this, but I think like drop shadows in Android seem to be particularly weird. Like you get the elevation or the Z translation or whatever for free, but if you want to do like real custom stuff, it becomes a huge pain. And again, with iOS, you get those default Apple widgets, and if you don't, you got to really struggle to make your own totally own custom widgets. Our designers have absolutely loved that we've componentized these things in a way that is reused all over the place, is reused between what they consider iOS and Android. And then QA, there are just less bugs. I mean, you're not literally writing the same thing twice. So obviously still want to QA it on both iOS and Android, but you just don't run into the same quantity of bugs because it's kind of half the code. All right, stability. So again, I'd kind of mentioned our specific situation working with, people who may be experiencing like suicidal ideation, and we don't want to frustrate anyone in a precarious situation. But I highly recommend, and this kind of sets everyone's minds at ease, use feature flagging, right? Like the first thing you build in Flutter, find a feature flagging, solution if you don't already. I mean, you get Firebase, you get LaunchDarkly, there's a million out there. And just flag the Flutter stuff. If anything goes wrong, you could roll it out slowly. If anything goes wrong, you can just turn it off and go back to native stuff. But highly recommend feature flagging. It seems to set everyone's mind at ease. All right, ROI. Huge caveat. This is super back of the napkin math. Let me move my presenter view window. Here's essentially what we've done. The ROI gets better over time, right? I think that is pretty obvious. There's a certain number of stories that are more expensive to develop in Flutter at the beginning, but again, not significantly, because iOS plus Android often, even at the beginning, is just equivalent to Flutter, maybe a little bit more expensive for Flutter. But as we've componentized and learned to love hot reload or hot restart, we're seeing certainly not all features yet, especially with areas of the application that aren't like largely already reusable components in Flutter, but specifically like ADA stories, right? Accessibility type stuff. If anyone's worked with accessibility in iOS or Android, unbelievably frustrating. It's something that, when it rolls across the backlog, there's like an inaudible groan from all the mobile developers. We're like, oh man, an ADA story. ADA is piece of cake in Flutter. It just is so easy, works perfectly between iOS and Android, amazingly, even though within Android itself, like a Samsung versus a Pixel phone may not work the same with TalkBack. But so that leads into a lot of like improved developer happiness, right? Hot restart plus some of those previously frustrating stories being really easy. Plus just the fact that if I write something in Android, I had a lot of fun writing it in Android. I, overcame all the challenges. I understand it now. Writing it in iOS just feels like what it is, which is a bunch of duplicative work. But anyway, so let me dig into some numbers, right? We spent about $15K for our initial third-party engagement with the Ukrainian contractor. And then again, wild estimate, but when, again, we consider the like iOS plus Android and then Flutter diff, I'm talking about the little diff up here. So if it's 10 hours for iOS plus Android and 12 hours for Flutter at the beginning, I'm taking 2 hours as the diff there, right? I don't think as part of the cost, you should count all 12 hours because you would have had to have spent 10 writing it in iOS and Android. So wild ass guess, we have 3 mobile developers on the team. I'm figuring, maybe 2 weeks of time per developer at a, cost of $100 an hour, whatever. Say over 8 months, we spent an additional $25K that we otherwise would not have spent had we just built it in native. What that kind of ends up looking like, and again, back of the napkin, so don't be too angry at me, is if we kind of plug in those numbers, right, and we take our 3 developers with 48 hours of developer time per 2-week sprint, and again, you're saying, Ryan, why 48? Because I think if you look really carefully at how much time developers actually spend developing, you'll be like sadly surprised that it's not, as much as you'd hope it would be, with, agile ceremonies and, what have you. And then just a super even number, $100 an hour. You get like a 15K cost per sprint. And if you kind of break that down between like the 40K original cost, right, 25 plus 15, and divide that by the cost per sprint times what I'm estimating to be an average of a 10% cost savings. So certainly not going to call it like a 50% across the board development time improvement cost savings, right? That's absurd. So I'm going to go like really low with it. You could call it maybe 5 to 10%. You get that return within, 1 to 2 years, which again, depending on your situation, feels super worth it because it's not just strict money. Again, you get that kind of developer happiness. You also get, more features within the same time period because again, if you're not writing the same thing in, iOS and Android for 10 hours, when you start to approach that 50% development time improvement, maybe the one feature takes 5 hours and a whole other feature takes 5 hours. So you get, twice the features. And again, I do just want to reiterate, because I sometimes feel silly saying a 50% development time improvement. I do not think that just by writing in Flutter, you get, you're writing at twice the speed, because I think if I build something in iOS, again, I figured out all the complexity. I write something in Android, it doesn't take 5 plus 5 hours. It takes like 5 plus maybe 2 or 3 hours to do the other one. But again, what you got to keep in mind is the hot reload is like unbelievable. It's honestly, it just saves might save an hour a day. It's like absurd. All right. We can maybe talk more about that math at the end if anyone wants to. So here's, I think at the end of the day, your proposal essentially looks something like this. Go with an add to app architecture so you can balance the long-term wins. Throw feature flags in there so there's no risk at all as you're rolling out this brand new technology to customers. Possibly find a third party. It can be super cost efficient, and the knowledge transfer for us was amazing. Being able to look at, again, a feature that we already well understood, just in a new kind of language and concept, really kind of made it hit home as far as understanding all right, this is Flutter, this is how it works. Now we can run with it from here. Make sure developers are bought in, make sure everyone's bought in, everyone understands what the wins are going to be. And, share some of those efficiency wins. All right, talking architecture. All right, where am I? I'm at 37 minutes. Okay. All right, not doing too bad. Hopefully no one's asleep. All right, architecture. Oh, sorry, I lost my little presenter view. 1 second. Yeah, come back, buddy. Okay. Engine. So we'll talk about some of the more technical stuff now. Right, here we go. So when we're talking about different architectural approaches, I think, again, at the super highest level, you get the greenfield approach where you're building from scratch, where you get the add to app approach, where you're throwing small pieces of functionality into existing native applications. Flutter supports view controllers in iOS, and then activities, fragments, and views in Android. So the reason I kind of mention that is because anything you present within your existing native app that is Flutter is running in an engine, a Flutter engine. It's a runtime for Flutter applications. It's got all of Flutter's good stuff in it. And so the bottom line is, again, if you're showing a Flutter screen in add to app, it's running in an engine. And so what we're going to spend some time talking about is the different architectural approaches you can use for managing engines. We tried 3 of them and got it wrong twice, and are happy to kind of share our final win with you. I have a little kind of pseudocode down here just to make it really clear, hopefully really clear what's happening. Bottom line is you create an engine, you inject the engine into a Flutter view controller. This is iOS, obviously. And then you can present that home Flutter view controller instance just like you can any other view controller, because it is one. It's a Flutter view controller is a subclass of UI view controller. All right. So we're going to dive into, oh yeah, right. Super important. You can have multiple engines, and that's going to be a big part of kind of the architectural differences here. And we'll talk about like why you may or may not want to have that. But the most important concept is that like not all memory is shared between multiple engines. Just kind of keep that in the back of your head. Meaning that if I have screen 1 and screen 2 in Flutter and they're running in separate engines, and I make a network request in screen 1 and save that, resulting model object in the in that Flutter instance, the second one does not have access to that. And so that might, immediately start you down a mindset of like, okay, well, you probably just want a single engine there so you can share all that goodness. And you would be wrong. So I lost my presenter window again. Well, you may not be wrong. I mean, there's a million different approaches and pros and cons to each one, but we'll jump into the single engine first. So our hypothesis, and I'm basically going to read right off the slide here. I know that's bad practice, but here we are. Our hypothesis was that using a single engine and navigating to different screens within that engine, right? So I click a button and I, present a screen in Flutter. And maybe it's it's a list view screen. When I'm done with it, I close that screen. I go somewhere else in the native app and I click on another button that has to present a totally different Flutter screen. I'm going to say, hey, engine, because I've held on to that engine, navigate within Flutter to Flutter screen number 2. All right. We hypothesized that by doing that, we would reduce the loading time, right? We don't have to wait for the Flutter engine to instantiate. It already exists at like app delegate startup time, or your Android application class. And we would allow the Flutter instance to hold model objects and share that memory across the screens, right? So if you kind of consider like long-lived versus short-lived data, where like long-lived might be information about a user that doesn't change, right? First name, last name, date of birth. And short-lived might be a number of like activities they have assigned, right? Go for a walk, go for a run, listen to a relaxing audio guide. First name, last name, date of birth, that lives forever, right? You make that network request once when the app starts, you can basically use that. You never have to bother the server again. The number of activities, that could be changing all the time based on what the user's doing. So we figured, hey, let's use a single engine. Let's hold on to those model objects that are long-lived and short-lived if needed. And we can reuse those resources across different Flutter screens. We don't have to make a bunch of network requests that are like duplicative, which we would if we had multiple engines. But the reality was, once you start layering screens on top of each other, meaning like native screen 1, click a button, go to Flutter screen 1. Click a button within Flutter screen. Maybe you have to go back to a native screen 2 because that thing isn't migrated yet. And then there's another Flutter screen on top of that from native screen 2, which is this example down here at the bottom. The state management becomes literally somewhere between a nightmare and actually technically impossible right now. Because what happens is a Flutter engine can only have one. Wait, what? Do I have it backwards? No, a Flutter engine can only have like one view controller associated with it at a time. And so what happens is you end up like losing state between the time you are on Flutter 2 and need to like go back to Flutter 1. And if you try to say like, hey, engine, inject like another instance of a Flutter view controller in there, it literally, like it appears to be possible in the code, in like the Flutter code, but it doesn't actually work. And we spent days and days like banging our heads against this problem, trying to get it to work. And it just does not. And I think, again, this speaks a little bit to the immaturity of the add to app solution relative to something like Greenfield and Flutter. But again, I think it's something that maybe in another year or so would be like, rock solid. But that's, at least today, like single engine is impossible if you're doing the add to app componentization, where you may have to go native Flutter, and then back. You just like can't do it. So then we went with the solution of a long-lived engine group, where we thought, hey, we don't want to pay the startup cost every time we, open a Flutter screen. So let's we've got 4 Flutter screens right now. Let's instantiate the engines for them at app startup. So it's called pre-warming in Flutter parlance. And it's a thing they suggest you can do. And we'll hold on to those engines. And then when we need them, we can just present them. What we ended up finding was the state within the Flutter engines themselves was really hard to manage. So with the single engine, it was the state on the native side that was hard to manage. State of the engine on the native side. With these long-lived engines, it was the state of stuff within Flutter. So if I instantiate an engine, log in as a user, do some activity in Flutter, and then go back to native and log out, that engine is still sitting there. It's still got all the state from that logged in user. How do you clear that? Like maybe you harken back to one of the platform channels we talked about earlier. It just becomes super messy and risky to try to have these things that should not live beyond a user's session that actually do live. And so you say to me like, hey, Ryan, why don't you just destroy the engines when the user logs out and reinstantiate them? And I say to you, that is, obviously what we tried to do, and it's just technically impossible. You reinstantiate the engine, and like the app would crash. There were so many weird scenarios we ran into trying to reinstantiate an engine on the same screen and add it to what they call a Flutter engine group. That again, I think speaks a little bit to the immaturity of the app approach. And so after spending a lot of time with these 2 different architectures and failing miserably with both of them, we jumped into a short-lived engine group. And this is the choice we kind of stuck with. And the hypothesis here was that if we tie the life cycle of a Flutter engine to the life cycle of the parent, view controller fragment activity that it's in, all the complex state is handled for free. And then we also layered in another piece, was if we think judiciously about which model objects should live natively versus in Flutter, we can eliminate a lot of unnecessary API calls. Because that knowledge isn't shared between Flutter instances, I would normally have to make a user object call in instance 1, a user object call in instance 2. But we ended up trying to identify the long-lived versus short-lived data and creating platform channels between the native code and the Flutter code that would allow us to say, all right, Flutter code needs a user object. Why don't you ask the native code for it? The native code stores that model object and then just hands it to whichever Flutter instance requires it. So reduced a lot of those unnecessary API calls. And it turns out that one of the fears that we'd kind of lived with from the beginning, which was that engines would take a long time to start up, just isn't true. It was a little bit of a fallacy that we ran into because in debug mode, they would take a long time to start up. But as soon as you put Flutter into release mode, those engines start up instantly. It's 50 milliseconds or something like that. So that was really cool. And that's what I would recommend, is tying an engine to its parent, view controller, fragment activity, whatever. So quick thing on platform channels, we talked a little bit about it earlier. Again, communication method between native and Flutter code. super easy. You just pass JSON back and forth, like JSON string, whatever. Supports async operations. It can even be made, this is brand new. And we haven't implemented it yet, but I was reading through Flutter's documentation the other day. You can make it type safe now with this Flutter dev team created package called Pigeon, which sounds amazing to me, because right now it's not type safe just by default. And so what this kind of ends up meaning is when you communicate back and forth, it's literally just kind of like another network layer. Just like you talk to your server with, you literally can just do this. You serialize into JSON, you pass it over the platform channel, Dart deserializes it, and vice versa. Super, super easy to work with. So my suggestion for where to start, and this is what either worked for us or we wish we had done at the beginning, is to identify an area of your code base that's relatively standalone, that'll also generate lots of reusable components. So you don't, in my opinion, you wouldn't want to start with, all right, we've got a really complex screen. Let's take one small view of it and transition that to Flutter. You end up with like a lot of platform channel overhead and like weird lifecycle stuff. And so what I would recommend is find a screen that the logic for it is relatively standalone, and you can extract the entire thing, throw it all in Flutter, generate a bunch of those reusable components for future screens that you'll migrate. And that ideally, again, to reduce some of the platform channel burden at the beginning, has like quote unquote short-lived data. So you can then make the network requests right in Flutter rather than, again, having to go through platform channel. All right. That is everything. I hope people were able to follow that. Thank you so much. Does anyone have any questions?
Thanks very much, Ryan. That was great.
Chat is blowing up. There's nothing.
I think there's some typing going on. All right, so first one is, can you talk a little bit about unit testing in Flutter?
Yeah, super easy. So one of the like most common, I think, design pattern is like these business logic components that literally hold all your business logic. And Flutter has some super awesome like default dependency injection stuff built in. And so it almost forces you a combination of like the business logic component, the block logic with the declarative UI, like essentially forces you to separate your responsibilities in a way that you can just super easily, like, again, inject the mock dependencies if needed and test both things. Can you talk about encryption techniques, like anything built in or need to do by platform channels? I'm sorry, I wish I could answer that. I don't know anything about it. I'm going for honesty here. I don't want to just blow smoke. Any others?
Here's one. Any Android or iOS specific issues that you ran into, which would work fine on one but not the other?
Yes. So hot restart on a physical iOS device or hot reload would not work for the longest time. And we found out that there was a special, so in iOS, you have like your info.plist file. What we realized we ended up having to do was separate that out into like a debug versus release info.plist file, and add a special like bonjour service line into the iOS info plist, which allowed the, I don't know which direction the communication goes in, but allows basically like the Flutter debug instance to recognize that the phone is like broadcasting a signal to try to debug on. So that's like a development experience thing. As far as like actual code, that appeared very different in iOS versus Android. Nothing I can think of offhand, which I think again speaks to the nature of it not being an abstraction layer, it actually rendering its own thing. Oh, you know what? It is something. The life cycle methods can be kind of hairy to play with. I don't remember the exact details, but obviously like an activity and fragment versus a view controller all have different like life cycle methods triggering. And so there is Flutter like does its own thing where you can like listen to when a screen shows up and stuff like that. But I remember it didn't always either work the way we expected it to or like work perfectly in each situation. So I remember having to play with that a little bit.
What was your approach for bringing the development team up to speed on Flutter? Was kind of everyone responsible for learning it on their own, or did you do a group study plan or anything like that?
Yeah. So the third-party contractor who did the original kind of like migration for us took an existing feature and migrated it. We all reviewed those pull requests. We all also, I actually forgot to mention this, but I think it was in one of the slides. We bought a Coursera course or something that we all ran through as much of it as we could stand. But I do think reviewing the MRs and then like playing with the code was the best way to actually learn it, especially if you already have like context into how that specific feature works. So we did that, and then we literally just forced ourselves to like each pick a feature, again, kind of a standalone individual lightweight feature in the app, and translate it over to Flutter. And that was the one that like, I think really made it click for everybody. Because it forces you to do the block logic and the declarative UI and the unit tests and platform channels in some cases and all that good stuff. So really recommend for each person, like, I don't know how big your team is, maybe pair program or something, but take a standalone tiny piece of the app, single screen, whatever, and translate it over. It like forces it down your throat how to learn it. Does it increase app size a lot due to? No, I don't have the exact numbers here, but Flutter like brags about it on their website if you check it out. It's super tiny. I think each engine is like a handful, a couple dozen kilobytes or something like that. I really appreciate everyone sticking around and listening. I hope someone can take something valuable from it. Really appreciate it.